Guys, in this video we are going to see an example of phasor. In this particular problem we have asked to find out the voltage across this capacitor. Here we have a time domain circuit. We are going to convert this time domain circuit into phasor circuit. Then we are going to find out this voltage. After we find out this voltage, we are going to convert that voltage back into time domain. Okay, now here we have two current sources, right? So when we have two current sources, we have to calculate the voltage individually because we cannot do them together. There are some rare cases you can use the trig identity to combine them together, but most of the time it doesn't work. We have to do them separately. So what we are going to do is we are going to keep one of the source, we are going to cut off the other source, and we are going to calculate the voltage. Let's call that one V prime, and then we are going to keep this source and we are going to cut off this source, and we are going to calculate the voltage across this capacitor. Let's call that one V double prime, and after that we have to add them together. Okay, and also we have this inductor and this capacitor. So when we convert inductor from time domain to phasor, that's going to turn into j omega L. Okay, and when we turn the capacitor from time domain to phasor, that's going to turn into negative j over omega c. So these are the two things we have to know in order to convert this one. Now let's go ahead and do that. Here we have 3 cos 100t plus 62 degree, and let's write convert to phasor, and we are only using this source. So 3 cos 100t plus 62 degree source only. Okay, now let's go ahead and convert. When we convert this current source into phasor, we are going to keep this amplitude and the angle, that's it. So this is going to be just 362 degree. And then we have this inductor. When we convert this one into phasor, we have to use this equation j omega L, and in our case omega is this value, the value that multiplies the t, that's our omega, 100, right? So let's write this one down here. Omega is equal to 100. So 100 times 0, 0.001, that's going to be our inductor. So this is going to be just 1j. Okay, 1j. And when we convert resistance into phasor, resistance remains the same, it doesn't change. So this is going to be just 2 ohm. And here we have a capacitor. When we convert capacitor into phasor, we have to use negative j over omega c. So if you do that for this one, this is going to turn into negative 4.55 j. Okay, so this is our new capacitor, and then we are going to have 3 ohm, and here we have 5 ohm resistor, and also we have another capacitor. When we convert this one into phasor, this is going to turn into negative 2.13 j. Okay, and that's it. And we are going to open this part because we are removing this source, because we only use one source here. Okay, so we are removing this source, so this does not exist, and that's it, right? Now we have converted this one here. Now all of the converted, this capacitance and inductance is now impedance. Okay, so this is same as resistance. So when we have resistance in series, we add them together. When we have the resistance in parallel, we use the product over sum to combine them together. Here all of them are in parallel, because you can see these two are in parallel, these two are in parallel, and also these two are in parallel. So we can do the product over sum to combine these three together, and if you do that, that's going to give us a new circuit. Let's go ahead and draw that one. Here we are going to have this current source, and that's going to be 362 degrees, and if you do the product over sum for this one, that's going to turn into this is going to become 0.4 plus 0.8 j plus 0.8 j. Let's write with a different color. Okay, let's write this one with a different color. Here we have 0.4 plus 0.8 J. Okay, so this is our new impedance, and we are going to do the same thing here. Here we are going to, if we combine these two together, that's going to give us 2.01 minus J 1.38. Okay, and also we are going to combine these two together, and if we do that, that's going to give us, this is going to give us negative 77 minus J 1.80. Negative 77 minus J 1.80. So now we have combined these three impedance, like three parallel impedance together. This is our new circuit. Now let's see what we can do from this. Here we have this current source and this impedance here, and when you have voltage source, like when you have current source and the resistance in parallel, you can do the source transformation, right? To find the source transformation, we use the V is equal to IR. So we convert the current source into voltage source, then we keep the resistance as it is, right? So here we do the same thing. V is equal to IZ. Z is impedance, and we convert this current source into voltage source, and we keep this in series. Okay, let's go ahead and do this for this one. Here we have the current that is 362 degree, and the impedance is 0.4 plus 0.8 J, and if you multiply these two together, you are gonna get 2.68 125.4 degree. So this is going to be our new thing. Let's go ahead and draw that one. Here we are going to have voltage source, so this is going to be plus minus, and let's put the value. That's going to be 2.68 125. Okay, let's write this clearly with a different color. 2.68 125.4 degree. This is our voltage source. Now this resistance, this impedance is going to be in series, so this is going to be 0.4 plus, it doesn't change, okay, it doesn't change, it's going to be 0.4 plus 0.8 J, and this is going to be now in series with this one, 2.01 minus J 1.38, and these two are in series. Our new circuit is going to look like this, and we are going to have this one here, this negative 77 minus J 1.88, and that's it, right? This is our circuit. Now when we have resistance in series, we can add them together. We do the same thing for impedance. When we have the impedance in series, we can add them together. If you add these two together, that's going to give you, let's draw the new circuit here. We are going to have the new circuit that's going to be with new impedance, and that impedance is 2.41 minus J 0.58, and we are going to keep the other one because our purpose is to find the voltage across this capacitor. That is this part. Okay, this whole part is the one we are interested in. Now let's try this one here. So let's say this is plus or minus voltage V prime, plus or minus V prime, plus minus V prime, and here also we put plus minus V prime. This is the one we are interested in, so we keep this impedance. This is 0.77 minus J 1.80. Okay, so we have this one, and also we have the voltage source that is plus minus, and the value is 2.68 125.4 degree. Okay, now we can go ahead and do the voltage division to calculate the voltage across this impedance. Let's continue that part here. Okay, so the bar we are going to have V prime, we are calculating V prime. Our voltage source is 2.68, 125.4 degree, and to find the voltage division we keep this one on top. This is the voltage, we are trying to find the voltage across this this impedance, so that's going to be on top. So that's going to be 0.77 minus J 1.80 divided by addition of these two. Okay, if you add these two impedance together, you are going to get 3.18 minus J 2.38, and that's going to give you this value, that is 1.32, 95.37 degree, and this is in Phasor. So when we convert this one into time domain, we are going to get V prime of t is equal to 1.32, and then we had to put cos omega t. In our case, omega is equal to 100. We had this one previously, so this is going to be 100 t, and then we are going to have the angle, that is this one, 95.37 degree. Okay, so this is our V prime. So we only used one source here. Okay, so we had to now find the voltage using the other source, so we had to redo the whole thing again. So let's note this value here, because we have to get rid of this part. We need another, like, we are going to do the same thing all over again for the other source. So let's note this V prime somewhere here. So let's note this one here. V prime of t is equal to 1.32 cos 100t plus 95.37 degree. Okay, so this is our V prime using one source. So let's box this one. So this is one source. Now we have to find out the other source. Let's bring that one back here. Okay, we have to do it for the other source. Now let's get rid of this whole thing. Okay, let's get rid of this whole thing. Okay, here what I'm gonna do, I'm gonna just get rid of these things. Okay, okay, let's erase this part here. Okay, now we can go ahead and draw the new circuit. Now here what we are going to do is we are going to keep this circuit. Okay, keep this one, 2 cos 80t. So the only source is only 2 cos 80t, and we are going to convert into Phasor. So convert to Phasor, and when we convert to Phasor, we are going to use the same equation. When we have inductance, we are going to use the j omega L. When we have capacitor, we convert using minus j omega L, but in our case omega is equal to 80, because in this source this is our omega value, right? So omega is equal to 80. Now let's go ahead and do that. J times omega times L. Our inductance here 0.01, and if you multiply this one with 80, that's going to give you 0.8J. So this is our new inductance, and the resistance remain the same. That's going to be just 2. And here we are going to have this capacitor. That's going to be negative j over omega c. So negative j over omega c, that's going to give us negative 5.68 j. We are using this capacitance to calculate this new capacitance in the phasor, and that's going to just stay the same. So this is going to be just 5. And also we have this capacitor that's going to be turned into negative j over omega c, and if you calculate this one, you are going to get negative 2.66 j. And here we have this current source. When we convert this one into phasor, we just keep this amplitude and the angle. Since we don't have the angle provided, that's going to be 0 degree. So this is going to be 0 degree. Okay, now this is our new circuit. Now let's see what we can combine here. Here we can do the same thing as we did before. We can combine these parallel impedances, because when we convert this capacitor and inductance, this is going to change into impedance. So we have impedance here, we have impedance. That when we do that, we are going to do product over sum, like same as resistor. So when we do that for this one, this is going to turn into 0.743 and 68.2 degree for this part. And for this one here, we are going to have, let's write with a different color. This is 0.743, 68.2 degree, and here we are going to have 2.633, negative 27.8 degree, and for this part we are going to have 2.348, negative 62 degree. Okay, now this is our new circuit. Okay, so here we have this one, and that's it. And also we have this current source here, that's gonna be 20 degree. Okay, so this is our new circuit. Now let's see what we can do here. Here we have these two are in series, so we can add these two together. That's gonna give us, let's draw the new circuit here. That's gonna give us this value, that is 2.68, and negative 11.8. This is our new impedance when we add these two together, and we are going to keep the other one because our purpose is to find out the voltage across this one. Okay, voltage across this one, let's keep this one here. This one is 2.348, negative 62 degree, and also we have this current source, that's going to be this one, 20 degree, and that's it for this circuit. And let's see what we can do here. Here we have this current source with this one. Here we can find the current, because we can use the current division to find out the current going through this one. And since we have this one downward, let's assume the current is going in this direction, and we are trying to find the voltage across this. That's our purpose. Okay, let's call this V double prime. Let's go from here. This is plus or minus V double prime. Here we are going to have plus or minus V double prime, and this is V double prime. And let's find out the current. To find the current, we can use the current division. That's going to be, the equation is going to be I is equivalent to, let's use a different color. I is equivalent to, here we have the current source, that's 200 degree. Then for the current source, what we do is we use the other one first. For the voltage, we always use the one we are dealing with first, but for current source we use the other one on top. So this is going to be 2.68, negative 11.8, divided by the addition of these currents. That's gonna give us 2.68 negative 11.8. This is this one plus this 2.348 negative 62 degree, and we are going to calculate the current through this one, and that's going to give us, and also okay, so let's find out the current, and the current is going to be 1.177 23.3 degree. Okay, so this is our current. Now we can use this current to find out the voltage, because we know that V is equal to IZ. So here we are trying to find V double prime. V double prime is going to be equal to IZ. In our case, I is this one, and also this is going to be negative, because if you notice the direction, this is going from negative to positive, so we have to put a negative sign in front. So negative, our current is 1.177 23.3 degree. That would multiplied by this impedance, that is 2.348 negative 62 degree. Okay, and when you calculate, you're going to get 2.762 141.3 degree. So this is in phasor. When you convert this one into time domain, this is going to turn into, this value is going to be first 2.762, and then we are going to have cos omega t cos, but here we are using this current source. In this current source, omega is equal to 80, so this is going to be 80t plus this okay, this one plus the angle. Here the angle is 141.3 degree. So this is our second voltage. Okay, so this is V prime. We found out V prime using the first source, that is this source. Okay, we found out V prime using this source. Now we found out V double prime using this source. The final voltage answer, the voltage across the capacitor, across this capacitor, is going to be addition of these two. We had to add them together. Let's go ahead and do that. Let's box this one down first. This is one of the other answer. Now let's get rid of these parts, because we have to write them together. Okay, let's get rid of some of this part. And we can write our final answer here. Okay, now we have enough space to write our final answer. So we can write final answer. Let's take this one out. Final answer. Answer is going to be V of t. That's our question. That's going to be equivalent to addition of these two. The first one is 1.32 cos 100t plus 95.37 degree plus 2.762 cos 80t plus 141.3 degree, and this is going to be our final answer. I hope this helps. Thanks for watching.